Let's do some multiplying and dividing rational expressions. First, multiplying. How do you multiply fractions? Like, what if you need to multiply 10/27 times 3/5? Well, multiplying fractions is one of the easiest things you can do with them, because you just multiply together the numerators and you multiply together the denominators. Just multiply right straight across. So 10 times 3 is 30 on top, over 27 times 5 is 135 on the bottom. And we have multiplied correctly, but this answer is not in lowest terms. It can be simplified. There are things that we can divide by on top and on the bottom to reduce or simplify this. But rather than do that here, let's go back to the original problem and see if we can do some simplifying or dividing out common factors before we multiply it all out. So 10 here, that's 2 times 5. 27 here, that would be 3 times 9, and then that 9 would be 3 times 3. So altogether, that's 3 times 3 times 3. So with everything broken apart into factors, we're looking at 2 times 5 over 3 times 3 times 3 times 3 over 5. So on top, we got a 2 and a 3 and a 5, all multiplied together. On the bottom, we got a 3 and a 3 and a 3 and a 5, all multiplied together. And we can cancel out some common factors. There's a 5 on top and on the bottom that we can cancel, because really that just means dividing the top and the bottom by 5. And we can cancel the 3 on top with one of the 3's on the bottom. So really we're just dividing the numerator and denominator each by 3. And now there are no more common factors, so it is in lowest terms. We got 2 on top, and we got 3 times 3, which is 9 on the bottom. So the answer in lowest terms is 2/9. That's equivalent to 30 over 135, but we divided by 5 and then by 3 on top and on the bottom. So this is the approach we're going to take, but the fractions we're going to work with are not just numbers, they're fractional or rational expressions involving variables. So here's our strategy for multiplying fractional expressions. First, factor anything that you can factor in the numerator or denominator of any of the fractions. And then cancel, which really means you're dividing out, any common factors that appear in both the numerator and the denominator. So look at some examples of this. 4y over 7 times 14 over 12y. What can we factor? Like, what can we break apart into something times something else? Well, the 14 would be 2 times 7. The 12 would be 3 times 4. And if we wanted, we could break these 4's up into 2 times 2. But since we have a 4 on top and a 4 on the bottom, we might as well just leave them as 4's and let them cancel each other. So we can cancel those 4's. And we can cancel the y's. There's a y on top and a y on the bottom. And do you see what else we can cancel? There is a 7 on top and a 7 on the bottom. So we can cancel those. And now what's left? Now we have just a 2 left on top over a 3 on the bottom. So in lowest terms, the answer is 2 over 3, 2/3. How about this one? 6a over b squared times b over 12a. So thinking in terms of factors, the b squared means b times b. That's what b squared means. We could pull the 6 apart into 2 times 3, but first notice there's a 12 here, and 12 would be 2 times 6. So if we just leave this 6 as a 6, we can cancel it with this 6 down here. Or we could break them both up into 2 times 3, and then the 2's and the 3's would cancel. But like I said, we can cancel out the 6's. We can cancel these a's. And we can cancel the b on top with one of the b's on the bottom. So there's nothing left to cancel. So what remains? Well, on the bottom, we still have another b and we have a 2. So b times 2, or 2b, is in the denominator. On top, we canceled everything. We divided by everything that was there. And what's left when you have something and you divide by that whole thing? 1. Anything divided by itself would be 1. So dividing everything away leaves you with a 1 on top over a 2b on the bottom. So that's the answer, 1 over 2b. Now how about this one? X plus 3 over 2x minus 4 times x minus 2 over 3x plus 5. Do you see anything that we can factor here? Can we factor x plus 3? No. Can we factor 2x minus 4? Well, I see a common factor of 2 that we can pull out. So we can write this as 2 times x minus 2. I don't see anything else we can factor. Can't factor the x minus 2 or the 3x plus 5. So here's what we got. I factored the 2x minus 4 into 2 times x minus 2. And that x minus 2 on the bottom can cancel with a factor of x minus 2 on the top. And then that's the only thing that does cancel here. So what we have left is x plus 3 over 2 times 3x plus 5. Now you can either leave it like this, with the 2 times the 3x plus 5 on the bottom, or you could multiply that out as 6x plus 10 on the bottom. So either one of these would be okay. I guess which one's better depends on what you're going to be doing with it. But if I ask you to multiply these and give me the answer in lowest terms or in simplest form, I would accept the answer in either one of these forms. So you could give it to me like this or like this. Aha, now there's a lot going on here. We got to start by factoring everything we can. So look at each thing we have here and figure out how to factor it. If you want to think about this, pause the video and try to factor everything that's here. Okay, so did you see all the factoring that we can do? 4a plus 8, we can pull out the greatest common factor there would be 4. So we can pull out a 4 times a plus 2. Down here, we can pull out a common factor of 9 times a plus 1. This a squared minus 1 is a difference of 2 squares. It's one perfect square minus another. That's a special factoring formula that you need to remember. So that is factored into a plus 1 times a minus 1. And then 2a plus 4, we can pull out a 2. So it's 2 times a plus 2. Now that we have everything factored, we can go looking for common factors that we can divide out or cancel. So what do you see that we can cancel? What factors appear as part of the numerator and part of the denominator? A plus 2, a plus 1, anything else? Well, the 4 on top over the 2 on the bottom, we can cancel out a factor of 2. The 2 on the bottom with the 4 would be 2 times 2. So when we cancel one of those 2's, there's one of them left on top. It's like the 4 over the 2. The 4 divided by the 2 just leaves you with a 2 here. And now we have reduced to lowest terms. There are no more common factors to get rid of. So we have 2 times a minus 1 on top over 9 on the bottom. You can leave it like that for your final answer, or you can multiply through as 2a minus 2 over 9, or you can think we got a 2 over 9 times the quantity a minus 1. All three of these are equivalent. I would accept any one of them as the final answer. So that's it for multiplication. I'm going to come back in the next video and we'll talk about how division works. And how it works is we take a division problem and we turn it into a multiplication problem. So if you can't do multiplication, you can't do division. But if you can do multiplication, division just has one extra step at the beginning.